Hello everybody, we're going to look at efficiency and electricity bills today. So last lesson we looked at energy efficiency. Efficiency can also be expressed in terms of power as well as energy. Remember, all power is energy divided by time. We express our efficiency as a decimal ratio. If you remember, it never went above 1. We cannot have anything that's more than 100% efficient. It simply doesn't exist in physics. It cannot be above 1. It cannot be above 100%. Now, if we looked at the equations we used last time, we used efficiency is equal to useful energy output divided by total energy input. Now, for power, it is exactly the same. Efficiency is equal to useful power output divided by total power input. Now, efficiency usually refers to the amount of useful energy that an appliance transfers. The higher its efficiency, the more useful energy is taken from the total input energy. The same calculation is done with power. Instead, it is the same calculation, rather than using energy, we are using power. Now, sometimes efficiency can be expressed as a percentage. You must be able to convert from percentage to the decimal ratio. Now, it's really easy. To convert from a decimal ratio to percentage, we times by 100. To convert from percentage to decimal ratio, we divide by 100. Now, when we talk about it in terms of our equation, still the same equation, but we have times by 100 to get it into percentage. Now, I treat these as two separate equations. I solve this part first, then I do this little part here. I'll show you some worked examples. So, a lamp has a total input power of 100 watts and a useful output power of 50 watts. We're going to calculate the following. First, we need to look at the power that's being wasted. And we do that by the following. Total power is equal to useful power plus wasted power. Always write down the equation you are going to use first before you put your numbers in. Then we're going to put our numbers in. We've got 100 watts is equal to 50 watts plus wasted power. Now we're going to make wasted power the subject of our equation by moving the 50 to the other side of the equals. So therefore, to get rid of a plus 50, we minus 50. So this side, it will be minus 50. 100 watts minus 50 watts is equal to wasted power. Therefore, wasted power equals 50 watts. The next part is we're going to work out the ratio as a decimal. And we're going to use the equation that we looked at on the last slide in terms of power. And we have got efficiency is equal to useful power in watts divided by total power in watts. Notice how we're writing the unit in our equation just to help us pick out the right information. Now we're going to plug our numbers in. 50 divided by 100 gives us an efficiency of 0.5. Now, this is the decimal ratio version of it. Sometimes what we need to do is convert it into percentage. All we simply do is we take our decimal ratio, our decimal efficiency, and we times it by 100 to give us 50%. Okay, so now we're going to look at going the other way. So a kettle is 85% efficient and has a useful power of 30 watts. Calculate the following, the total input power. Right, so what we need to do first is convert our percentage here into our decimal ratio. So we've got 85 divided by 100, it will give you 0.85. Then we go back to the equation we've been using previously. Efficiency equals useful power divided by total power. Plug our numbers in again. We've got 0.85 equals 30 watts divided by total power. Rearrange to make total power the subject of the equation leaves us 30 watts divided by 0.85, giving us a total power of 35.3 watts. Take it step by step. It is quite easy if we follow these steps. Write down your equation, plug your numbers in, rearrange, solve. Okay, so I'd like you to pause the video now and have a go at task 1. If you need a little bit more help, just rewind the video and look at my work through examples again and press play when you're ready to go on to the next task. Electrical appliances waste energy because the current in components and wires of an appliance will heat them up. This transfers heat to the surroundings. Electrical devices with moving parts such as motors also waste energy due to friction. This also transfers heat into the surroundings. Now, any exam question to do with energy, if it asks you where the wasted energy goes, your answer should be it transfers as heat into its surroundings at all times. This will get you loads of marks on your exam papers. So what we're going to look at now is part 2, electricity bills. Now, the electrical energy we use in our homes, it costs money, it costs mum and dad money. The more efficient an electrical appliance is, the less money it will cost to run. This part of the assignment will look at how to calculate electricity bills. And what we've done, we've broken it down into 2 separate parts where you'll be tasked upon. But in terms of reality, what we're really bothered about is why do we actually need to know this? No doubt, over this lockdown period, a few of you have been told off for playing too much computer. Now, with the information I'm going to give you, you will be able to work out a blast on the console or a cup of tea. Which one costs the most? So, in order to calculate how much electricity a device uses and the cost of its use, you need to be able to convert between different units. Now, this is the only time in physics that we don't really start using units such as seconds. If we was to look at electricity bills in terms of joules per second, the numbers on the bill would be astronomically huge. So we look at it in something called kilowatt hours. But before we do that, we need to be able to convert. So we're going to look at a couple of examples. So how many hours is 13,860 seconds? So when you first need to convert it into minutes, we know there's 60 seconds in a minute. So 13,800 divided by 60 gives you 231 minutes. Now we also know that there's 231, in those 231 minutes, there are 60 minutes in an hour. So there we go, 231 divided by 60 minutes will give you the time in hours. 13,800 seconds is the same as 3.85 hours. It is a case of converting seconds into minutes and minutes into hours. Remember, 1 hour 42 is not the same as not 1.42 hours. It's actually 1.7 hours. This is the thing that sometimes trips people up in our exams. 1.5 hours is actually 1 hour 30 minutes. Okay. Example 2, we're going to look at kilowatts. So how many kilowatts is 12 watts? Well, we know that there are 1,000 watts in 1 kilowatt. So 12 watts divided by 1,000 will give you the answer in kilowatts, 0.012. Ignore the 13,800 seconds. Remember, 1 kilowatt is equal to 1,000 watts. Now on your calculator, it may well show you in standard form, which is a different way of writing long numbers. It will show you as 1.0 times 10 to the power of 3, maybe even 1 times 10 to the power of 3. If you've got a Casio calculator, you've got a little button that says SD. If you press that, it will convert it into number form from fraction. Okay, so what I'd like you to do is complete task 2. So once I take down this big yellow sign in the middle, pause it and use what's on this screen to help you do the conversions. Pause the video now, press play when you're ready to go. So now we're going to look at the equation involved. So we know that power is energy transferred divided by the time taken. Now we're used to doing it in joules per second. We've got energy transferred is equal to power times time taken. This is just a simple rearrange of this. We've done this. Now, energy transferred in joules is equal to watts, joules per second, times time in seconds. So, all we're going to do now is rearrange this to make it useful in terms of your electricity bill. Now, what we do on our electricity bill, we talk about it in terms of kilowatt hours. It is the same thing. 1 kilowatt hour is called a unit of electricity. Our companies charge you per unit. If we use these in our electricity bills, the units would be huge, really, really large, and make your electricity bill really difficult to use. So what we do, rather than using watts, we use kilowatts, and rather than using seconds, we use hours. It really is that simple. There's no difference in the equation. A kilowatt hour is equal to kilowatts used times time in hours. Now we've got our horrible formula triangle there that's going to help you through it. I'm going to talk you through a few worked examples. This is one of these concepts that seems really confusing, but actually it's not. We are just changing the magnitude of our units. The equation is the same. So let's look at this one then. So a PlayStation 4 uses 250 watts of power. How many units of electricity does it use in 3 hours of gaming? So all we're going to do is we're going work through it. So units of electricity is equal to number of kilowatt hours. Units of electricity is equal to power, kilowatts times time in hours. That is it. So let's plug our numbers in. Units of electricity, we've converted our 250 into kilowatts, giving it 0.25. Remember, 250 divided by 1,000, 0.25 times the time, 3 hours. The units of electricity that your Get PlayStation is used is 0.75 kilowatt hours. That is it. Now we're going to look at it a different way. So we've got a pair of GHD hair straighteners, operates with a power of 300 watts and uses 0.15 kilowatt hours of electricity. How long will they use for? We're going to rearrange our equation for time before we do anything. So time is equal to the number of units in kilowatt hours divided by power, as we can see in our formula triangle. Remember, you cover it up, whatever you're looking for, what you've got left will give you your equation. Put our numbers in. Time is equal to 0.5 kilowatt hours divided by power in kilowatts, remember, so we need to convert our 300 into kilowatts, 0.3. So the hair straighteners we use for 0.5 hours. That's 30 minutes. Okay, so what I'd like you to do is have a go at task 3 on your worksheet. I'm going to leave the formula triangle here so it can help you. Remember, at all times what you need to be doing is converting your units into hours and kilowatts, otherwise the equation will not work. So press pause on the video, answer the questions on your worksheet, press play when you're ready to go. Now what we're going to do on this is just add to the equation you've just been practicing. So the cost of electricity is the number of units of electrical energy multiplied by how much it actually costs per unit. So cost is equal to number of units times cost per unit. It's a nice easy equation. So in our examples that we looked at earlier, the PlayStation used 0.75 kilowatts hours of electricity. What is the cost of the price of 16p per unit? Cost is, here's our units, 0.75 units times 16p per unit, 12p. So for 3 hours of PlayStation 4, it costs you 12p. Same again on our example for the hair straighteners. It used a total of 0.15 kilowatt hours of electricity. What is the unit? What is the cost at the price of 12 pence per unit? 0.15 into units times 12p, 1.8p. So it costs 1.8p to use the straighteners for half an hour. Remember, all we're doing now is using our kilowatt hours, which is the unit of electricity, and times it by how much it costs per unit of electricity. It really is that simple. So we're going to answer our question a little bit earlier. What's the most expensive? Playing your Xbox or making a cup of tea? So let's work it through. The average games console draws approximately 300 watts of power. Now, when we use the term draws, what we mean is it uses. You play Fortnite from 7 o'clock till 9:30. How much have you added to your electricity? Electricity costs 0.12 pence per kilowatt hour. So let's look at it. Step 1, we convert our units, 300 watts, into 0.3 kilowatts. From 7 o'clock to 9:30 is the same as 2.5 hours. It's 2.5 hours. Step 2, we solve our equation. So we write the equation we're going to use. It's going to be cost is equal to power times time times cost. Now, if we take these two here, that is your units of electricity, and then we times it by time. So kilowatt hours. So in this case, 0.3 kilowatts times the time we use the Xbox, 2.5 hours, times 12 pence. So your cost for using your Xbox is 0.09 pence. That's 9p to play your Xbox for 2.5 hours. That's not bad at all. Now, kettle on for a quarter of an hour, 0.25 hours. Remember, this is not 25 minutes, it is a quarter of an hour. Kettle is on for 0.25 hours, and there's a power rating of 1800 watts. So again, what we're going to do, we're going to convert everything into the units we want. So step 1, you convert your units. 1800 watts is equal to 1.8 kilowatts. 0.25 in hours, well, we don't need to do anything with that because it's in hours anyway. Step 2, we solve our equation. Again, we write our equation down. Cost is power in kilowatts times the time, in hours times the cost. Solve our equation there, so we'll put our numbers in 1.8, that's 1.8, when we've converted it, 0.25, we don't need to do anything, times 12p. Our cost is 0.054 pence to boil the kettle 15 minutes. I reckon 15 minutes is 5 cups of tea a day. So if you've got big tea drinkers in the house, you can argue this when they're moaning at you that, oh, who's paying the electric bill when you've been playing Fortnite for 5 hours? Or, it depends, to be fair, it does depend on how much water is in your kettle. If you've got 5 full kettles worth of water to boil, it will probably take more than 15 minutes. It costs you quite a lot of money. So, how this will actually look in terms of energy bills when your electricity bill comes through the door is as follows. So what we have is a meter reading. So we've got a previous reading, 771100, and a current reading of 845,900. Unit price, 9.2 pence per unit. Now, all we're going to do is use these as our equation. Now, it's an alternative way of looking at it. The units we've used is the current reading minus the previous reading. In this case, 74,800 units. £6,881.60 is the energy bill. Typical school, not our school, we're very energy efficient for the year. So, what I'd like you to do, pause the video, complete task 4 on your worksheet. Rewind it if you need further support. Go back to the walkthroughs that I've given you. Remember, it is all about converting the units first. That is imperative. In electricity bills, we convert to kilowatts, power, and we convert to hours per time. Always do this for your electricity bills. Okay? Again, rewind if you need to. I will be on hand if you need any help. Please send me an email through the week and I'll go through it again. I'll also put this PowerPoint up on the Teams website for you to go through under at your own leisure. Thanks, guys.